So we're going to be talking about probability of area, specifically a couple examples where we find the probability of hitting a shaded region. So first of all, the probability of hitting a shaded region would be the area of the shaded region written or divided over the total area. First, let's find the shaded area. In order to find our shaded areas, we're going to find the total area and we're going to subtract maybe an inner area, or in these examples, we're going to subtract out the white area. That'll leave behind the shaded area. So we have a few different shapes going on. In this first example, we have a triangle. So if we find the area of the total triangle, and then find the area of this white triangle, and subtract out the white area, that would leave behind the shaded area. To find the area of a triangle, we're going to do base times height. We're given both of those things, and we're going to divide that in half. So the total triangle would be 5 times 6 divided by 2, or 30 divided by 2, which is 15 square units. The area of our small white triangle is going to be 3 times 4 divided by 2, or 12 divided by 2, which is 6 square units. If we subtract those two things, that'll leave behind the shaded area. So 15 minus 6 is going to give us 9 square units. Now that we know the area of the shaded area, we can compare that to the total area, and that would be the probability of hitting the shaded region. So we got our shaded region of 9 square units and our total area of 15 square units. Write that as a ratio and reduce if ever possible. So 9/15 could be reduced, divide each by 3 and get 3 to 5. Or we could also write ratios in percentages. We could just divide this and then change our decimal to a percentage, so we get about 60%. So if I throw a dart and I know that it hits my shape here, the probability that it lands in the shaded area would be about 60%. So pretty good odds as long as we hit the triangle. Let's do the exact same thing but with a different shape. The copy didn't come out very good, but this outside ring is supposed to be shaded here. So again, let's do our area of the shaded region by finding the total area and subtracting out the inside or white area. So we're going to subtract out this tiny circle here. We're given diameters for our two circles. So the total big circle has a diameter of 6. That means it's got a radius half of that, which is 3. The area of the circle is going to be the radius squared times pi. So 3 squared times pi is 9 pi square units. Let's find the area of our inside circle. So it's got a diameter of 4, so its radius is going to be half of that, or 2. So the area of the inside circle is going to be 2 squared times pi, or 4 pi square units. Let's subtract those two things to leave the area of that ring, which should be shaded. So 9 pi minus 4 pi will give us 5 pi. Now that we have the area of the shaded region, let's compare that to the total area. So 5 pi compared to 9 pi. We can reduce or simplify those pi's. They cancel and go away, leaving with just 5 over 9, or about 56%. So a little less probability as if we hit the circle of hitting it in the shaded region than the triangle was. Let's do one more example. This time we'll use some rectangles or squares. Once again, this outside shape right here is supposed to be shaded, and this inside shape is going to be white. So let's find this outside area by finding the total squares area and subtracting this L shape from it. So since we have a square here at 10 by 10, its area would be 10 squared, or 100 square units. To find that area of the inside shape, we could cut it this way and just make a square and a rectangle, or we could cut it this way and make two rectangles. Either way you want to do it is fine. I chose to make a square here by cutting it. So if I had a total length of 8 and I can get 6 of it right here, that must have left over 2 to imagine right there. And likewise on the vertical length here, we had a total length of 5 and we know 3 of it, so that must also leave behind another 2 imaginary right there. So we have a 2 by 2 square. Its area is 2 squared, or 4. This rectangle is a 3 by 8, so its area is going to be 3 times 8, or 24. Combining those two things, we got the area of the L shape being 4 plus 24, or 28. So now we got the area of the inside shape. Let's remove or subtract that from the square, leaving behind our shaded region of 72 square units. Now we can compare the area of the shaded region to the total area, and we could write that as a reduced fraction or a percentage of about 72%. So there's kind of a quick tutorial on how to find area of shaded regions and how to find the probability of being inside the shaded region.